Well, hello everybody. Welcome into Great Atmosphere here on March 6th of 2024, Wednesday. Just wanted to do a quick apology for not having that Monday video out for you. I was quite under the weather earlier on this week. Just needed to take a day to make sure I could recuperate fully and be able to deliver to you a little Wednesday video that we got going on today. In terms of what we're going to be talking about, we're going to talk about the short-term systems that are going to be currently, as they are currently moving through our area, obviously, here on this Wednesday afternoon. And then our early weekend system that'll be affecting the southeast as well, Friday night into Saturday midday. Then also we'll take a look at the El Nino, just kind of, or the ENSO in general, see how those predictions are currently shaping out and what the consequences could be should we start to go towards some of the more extreme predictions that particularly our own NOAA Climate Prediction Center might be suggesting. Also, we'll take a look at the medium-term outlook as well to see how things are shaping up for the middle part of the month of March. But first, before we get into all that, just want to make sure that everyone knows to subscribe to the channel, specifically if you like these videos, these long-term forecasting discussions, particularly pertaining here to the southeast of the U.S., where I'm currently based here in Charlotte. But of course, any crazy weather I will have no issue talking about as well as it comes up. But let's dive right into it. So we do have our major, I wouldn't say major by any means, but our current low pressure system that is making its way across the mid-Atlantic as of right now. We see the majority of our rain here in the southeast has come to an end. We have some backfilling flow coming off of the mountains, just delivering a very foggy and misty day across the southern reaches of the Appalachian Range. And then in mid-south in Georgia, and the central regions of South Carolina, these ancillary storms are going to be popping up across the coastal plain all the way up and into the Carolinas and in North Carolina going into this evening. But ultimately, it'll just be isolated storms for the majority of the rest of the night. The main convective banding associated with these two individual low-pressure cells that we're seeing, we actually have, so this is the first generalized one right here, and then we have another one that's currently off the Maryland coast. Those two systems have these frontal boundaries that initially were very far apart, but now are very similar in where they are. So those are the two fronts, and then everything on the back end here is just colder and drier air, as we have ridging coming down from the primary parent ridge, or parent high pressure that is coming down from across the Midwest. We actually have some inverted troughing as well, going all the way up and into the New England states. So that's kind of the primary pushers and pullers with this particular system. Not a lot to write home about in terms of actual effects. I think we got about an inch of rain here, generally speaking, across the southeast from this system, but nothing severe, nothing really to write home about in that regard. We can take a look actually on what the NAM 3 kilometer is predicting the rest of the day out of this system. See the majority of the rainfall and banding start to move off by the evening hours of tonight, with some isolated pockets popping up across the middle parts of the Piedmont region of North and South Carolina, going into the overnight hours before we start to really clear out. And we actually have a very pleasant Thursday on our hands going into tomorrow. Should be relatively mild conditions and sunny skies throughout the course of the day. Hopefully dries us out quite a bit, because we're going to have another major system come our way beginning of the day end of the day, starting on Friday into Saturday. I don't really get to see that out of the convective allowing models here, but we can take a look at what the HRRR expects out of this one Wednesday remaining storm system. Largely the same that the NAM 3 kilometer is saying, with a little bit less so of a chance of isolated storms going into the Piedmont of North Carolina, pretty much keeping everything restricted down south. These are a lot of fog returns as well. Wouldn't expect a lot beyond just mist coming off the lee of the slopes of the Appalachians in that particular, or the Blue Ridge Escarpment, I should say, in that particular region there, according to the HRRR. We can take a look at what the total accumulated precipitation out of this event was going to be, according to the HRRR. We have areas that in the Piedmont and the Raleigh regions, Fayetteville, that might get up to about an inch, and then obviously closer to the Charlotte regions and in the upstate of South Carolina, where smaller thunderstorms, it was kind of more hit or miss, were appearing. before the heating of the day got involved with amplifying the convective banding of these particular storms over in the east. We only got maybe about a half inch or 3/10 of an inch in some of these areas. The overall upper level pattern that is associated with this event is we have our major subtropical jet stream extending across over the Baja of California del Sur, over Mexico, Texas, and up and into the southeastern reaches of the United States. With us particularly here, this is based off of European guidance about Saturday at 9 to 11 a.m. In this particular one, we have diffluent flow aloft, so we have areas where the air is diverging over here to be our main contributor of the convergent flow at the surface that ultimately creates that convective banding and rising motion associated with that, and that is particularly what we are seeing in this particular circumstance. We can take a look at the main thing that's going to be going forward into. Actually, let's take a look at what the upper levels look like for the system going into Friday and Saturday. So that is why we are the main theme for this particular system on Friday and Saturday is that we're going to be in the warm sector for a considerable amount of time, which will allow the atmosphere to regain and recuperate quite a bit of moisture as we get into that particular time period. Now, in this particular setup here, we do have quite a bit of, we're sitting in a very large diffluent sector, so the entirety of the southeast is currently encompassed within a lot of southerly surface level flow. The low level jet is going to be cranking with moisture going up and into the Ohio River Valley as a result. It should be a quite moist atmosphere going into the weekend. In addition to that, we also have the system that we are currently dealing with here today. I gotta get out of this current setup here. Just give me 1 sec. And we can see this outlined through the precipitable water indices that we have going into the system on Friday into Saturday. So we can see these PWatt levels are going to be highly accelerated as we go forward in time here, going up and into Mississippi, Georgia, and South Carolina with PWatts at 1.7 to 1.8. That is a lot of water in the atmosphere, a lot of precipitation loading associated with that, and we can see just how anomalous those PWatt numbers are by looking at the PWatt anomaly map going into Thursday into Friday. Quite dry on Thursday before we get into a lot of that moisture as it comes into Friday. And look at that moisture plume extending all the way up and into the Great Lakes states, but with these PWatt levels well above normal here, specifically in the deep southern regions of the United States, this is going to be quite a significant flash flooding risk going into Friday and into Saturday. And in terms of whether we are expecting severe storms out of this, I would say that the majority of any there's plenty of shear associated with the atmosphere, associated with the total profile of the atmosphere through those bulk shear levels are going to be highly elevated all the way throughout as we get converging air masses of that high pressure system into planes converging with the warm moist air coming out of the Gulf, and then we have the subsequent subtropical jet aloft, just kind of creating a lot of speed shear within the atmosphere as well, compared between the surface levels and the upper levels. So that is of no shortage. We can take a look at what the relative vorticity map looks like. And remember, we're looking for like kind of energy ribbons with this particular map. So you can see out here on Thursday, this is where the SPC has highlighted a good amount of severe weather convection over in the plain states starting tomorrow. That's where the primary risk area will be. And you can see why they think that based off of, you see these deep reds and oranges right next to these deep blacks. Anytime that those represent both anticyclonic and cyclonic vorticity advection, anytime that those two parameters are elevated in their own right and very close to one another is where we can expect to see a high amount of convective initiation and thus a lot of strength and energy behind those storm systems. So you can see that quite considerably across Texas and the Texarkana region going into Tennessee and Mississippi. And then we go into Saturday, and you can see that we have a little bit more of that on the front end, but nothing as severe and as widespread as we saw across the course of the plain states. The only areas where I see like it as a maybe would be pretty much around, let's move forward, would pretty much be like right around here. kind of in the Saturday night regions. You can see some darker blacks and reds right next to each other along the South Carolina coast around Charleston, Myrtle Beach, and then into southern Georgia, maybe extending up and into the coastal plain of South Carolina as well. But on the back end of that, we do get the main frontal boundary pushing through quite quickly. We'll have we actually can see the parent low eject another low, almost a cutoff that works to kind of, God, I love this, don't you? It works to effectively, you can see that go through time. We have our primary trough, which is what everything is based off of, is kind of like this, very positively tilted long wave trough. And then we have this cutoff low here that will sink down and ultimately work to kind of flush everything out to sea, and ultimately kind of cut off a lot of the energy that we would need to create a convective severe system across the majority of the Carolinas and Virginia and Tennessee and that kind of thing. So that's kind of going to be the valve shut off. How fast can this low sink far south so it can kind of push everything out to sea? That's going to be the main indicator of whether or not we get any severe weather further to the west. But I think the only areas I'd be concerned with would be to the east. We should be able to see that if I have this. Let's take a look at mixed layer Cape, actually. Let's see if we can kind of determine where that convective available potential energy is forecasted to be going into Friday and Saturday. You can see Thursday night we still have it over in the plain states before everything starts to shift over and into the southeast. Saturday midday afternoon, yep, that's pretty much around the same part that we talked about. Central Georgia, South Carolina along the coast into the North Carolina coast, maybe even touching the Newport News regions of Virginia as well. But very much limited in terms of any western Carolinas or northern Georgia severe weather. I would say this is mainly going to be a flash flood event for those particular areas. And we can actually see that this was just put out by the Weather Prediction Center, areas that they expect to see a chance of hazardous weather. This is the hazardous weather outlook. As that cutoff low starts to sink a little bit further south, we see high winds start to pick up across in the lee of the mountains. That's what is highlighted out of these high wind warnings. But this is all for that system that starts on Friday and Saturday. We have severe weather potential going from Big Bend to Florida and the Tallahassee region, or the Panhandle in general, all the way across southern Georgia. And then in this particular area, we have flash flooding possible across the majority of central South Carolina and central Georgia, with a elevated flash flooding risk and heavy rain extending from Point Charlotte, pretty much points due east, all the way to about Morehead City and the Sandhill region of North Carolina, all the way down and into the coastal plain of the southeast in general, into Alabama, Florida, and South Carolina, Georgia. So that is what we are looking at in terms of our system coming up. But there's another element to all this, and I want to switch gears here and talk a little bit about El Nino and what that means in the future. So we've taken a look at this in the past. We've kind of seen this is essentially a Pacific Ocean cross section. So this would be kind of the ocean surface here. This would be the bottom of the ocean, and in terms, and then this would be kind of like the western side of the ocean, and the eastern side, which is this is the Americas, right? And this is Asia, okay? And this is, remember, this is a cross section of the ocean. So at the surface here, we have the majority of it across the majority of the Pacific Ocean to be relatively anomalously warm, which is very on point with what an El Nino is, elevated sea surface temperatures across the whole of the Pacific Ocean. But every now and again, some of those trades will start to kick and start to diverge and go down, creating a lot of, I shouldn't say they go down themselves, but you get a lot of downdrafts in this particular region of the Indonesian oceanic archipelago, which ultimately works to cool the surface air and still start to downwell quite a bit of that cold water into there, and then ultimately it starts to work its way across the Pacific Ocean underneath. This is about 100 meters underneath the surface, and eventually it'll start to pop up again right around here. And you can see that at the surface now, for the first time in a long time, we have officially a anomalously cold pocket of sea surface temperature that has appeared off of the eastern Pacific. Something we haven't seen in quite a while. And let's see if we can take a look at what that map looks like. And you can see that cold pocket right here in the sea surface temperature anomaly map. This was predominantly all red and orange for the majority of the winter, and now we are starting to see that cold pocket appear. And remember, ocean and water temperature is the thing that changes last when it comes to major climatological shifts and stuff like El Nino. So when we see the sea surface temperatures change like this, where it's reflecting a colder environment, we know that a lot of other things outside of it, such as the trade winds and the Hadley cell and those kind of things, have already changed. And for those reasons of those changes is why the sea surface temperature changes. It's not it changes. It's a dependent change, so it will only change if something else has changed before it. So this kind of verifies that it is a weakening El Nino for sure, and we can expect it to continue to weaken based off of the guidance that we are seeing. You can see this is actually a comparison put out by the Australian Bureau of Meteorology that compares all of the major international model sets, CANSIPS, Euro, Japan, Meteo France, NOAA in the US, and UK Met Office, what they're all predicting in terms of what they expect La Nina and El Nino to come to, in terms of what their individual indices are based off of in the Nino 3.4 region. And you can see as we go forward in time, all of them pretty much by May, June are in the ENSO neutral range. By the time we get to July, NOAA particularly, so NOAA is obviously us here in the United States, is very, very, very bullish that we are not only going to be in a La Nina, but a Super Nina, as it's called, based off of the guidance put forth by the CFSV Tube Ensemble Mean Model. There's a lot of skepticism. There's healthy skepticism, I'll say, about the accuracy of this particular model. But you know, it's their current best guess here in the United States. And you can see that, you know, like they're expecting a crazy strong La Nina here. We have negative 1.5, just even some 2 degree below normal Nino 3.4 SST anomalies, according to their projections. And that would do quite a bit in terms of I would say significant weather patterns here in the U.S., because whenever we get a significant La Nina, what happens to the trade winds here along the equator? So generally speaking, with that cold air here across the eastern Pacific, they extend out and over and into the Indonesian archipelago, and that is generally the positioning of the trade winds. And what ultimately does that do if these are the dominant winds? Well, it essentially cuts off the North Pacific jet quite a bit. So it'll be kind of going along the lines of like this kind of pattern across the northern Pacific. And what that'll do essentially is all the energy is going to be elevated here in the Indonesian archipelago, and that's why it's going to be like a significant tropical event in that regard over in that particular area of Papua New Guinea and Indonesia and the Philippines. And then also we can expect probably an elevated hurricane season across this area as well. But a lot of that energy gets dissipated by the time it gets out and into the Gulf of Alaska. So what does that mean? It shuts off a lot of the temperature initiation in the Gulf of Alaska and off the Pacific coast of the U.S., meaning that temperatures drop quite considerably. And anytime you get sea surface temperatures that are anomalously cold, there's not a lot of moisture that the air above it can hold, and therefore there's not going to be a significant amount of not a significant amount of convective initiation going across the western half of the U.S. In a strong El Nino setting. So whenever, essentially what it means is that if you ever get a cold Pacific Ocean in the east, essentially for all intents and purposes, with the exception of maybe like the southeastern or the southwestern monsoon, it gets pretty dry, and it shuts off a lot of the moisture flow across the plain states. And conversely, what happens during an El Nino? Well, you get westerly wind bursts. So these westerly wind bursts will occur kind of like this, overall creating a dominant flow pattern that kind of goes in this kind of direction, splits off like so. and that's why we've had a cranking subtropical jet here. But ultimately, also what that does, it kind of makes the North Pacific jet quite dominant, and that's why we have such extreme atmospheric river events. This is not the dominant flow of the trade winds. You just get these little tiny bursts of westerly wind that ultimately work to create these processes in general. And these little amplifications here work to amplify the North Pacific jet, and that's why we got the atmospheric river Pineapple Express events that we've seen across the West this past winter. So that's effectively what we're looking at. And if the NOAA predictions come true and it becomes a super Nina, then a lot of concern happens now across the Midwest in terms of the expectations of drought. Now, starting from the beginning of February until now, it's been an exceptionally dry month for quite a few regions of the Midwest in Iowa, Missouri, Central Illinois, pretty much all points here in the Central Plains, in addition to some anomalous areas in North Carolina and particularly in New England. So it's been anomalously dry already. And then we also take a look at the temperatures, and the temperatures you've already had probably the warmest end of winter that the area has ever experienced in their history, especially in Minnesota, Wisconsin, and Iowa. So anytime that you have a very mild and very dry end of winter, coupled with a cooler than average Pacific Ocean and the prediction of a very strong super La Nina, those are all indicators that people will think back to some of the worst droughts that the Central Plains have had in history. You think 2012, and you even think back into, I believe it was 1983 or 84, something like that. Those were considerably devastating drought seasons for that particular region of the country, and they all started the same way, with exceptionally mild winters by way of a strong El Nino, and ultimately shutting off a lot. But ultimately, the El Nino shuts off quite rapidly, goes into a strong La Nina, and shuts off a lot of the moisture and temperature valve here in the West Coast, which ultimately propagates into, or it doesn't propagate into any severe anything coming out of the plains. I won't say nothing severe, but certainly a lot less than is necessary for like planting and crops and whatnot going into it. So that is generally kind of like, I don't want to say a prediction, but this is also something that's interesting. This is the 10 centimeter soil moisture percentile. So this kind of like measures aridity in a lot of the planting areas of the United States. And this is not good. If they're in the 2 to 5th percentile range, and probably these areas are some of the worst that they've been, and they're not going to. We've already had significant fire seasons here in the Panhandle of Texas. It's not shaping up to be the greatest start to the Midwestern planting season. That is for sure. So it's just something to consider going into this transitional season. Not a lot of predictability in terms of what the models. This is kind of like the worst series of months that the models typically have in terms of creating short and medium term forecasts. Just by virtue of increasing critical sun angles on different areas based off transitional seasonal changes. There's a lot of unpredictability that you can kind of, or more chaos, I guess, to the theory that gets put into some of these forecasts. But particularly, that is one teleconnection that we are quite concerned as meteorologists that this is going to be the predecessor of a significant drought coming for the plain states this year. Now, switching gears yet again to what we are expecting here temperature-wise in the medium term here in March of here in this new year of 2024. You can see this is the GEFS temperature anomaly map for days 0 to 5. Still very mild across the east and cool across the west. This has been kind of the placeholder in general model for the majority of February and so far March. Mild in general across pretty much the majority of the eastern seaboard. But you can see that there's actually some semblance of a change that's going to be making its way here. We have our dominant southwestern flow that is going to stay here for Thursday and Friday, according to the EPS ensemble here. So this southwestern flow is something that we're very used to at this point. I don't know where my particular, I think I might have lost my pencil graphic here, but we have southwestern flow, deep troughing in the west, and ridging out ahead in the east, which typically creates a flow pattern that creates a lot of moisture return here in the southeast. That's what we've been experiencing here for the past couple of weeks. But look at this little omega ridge that's set up here. So we have troughing over the coast of the Pacific Northwest, and then we have deep ridging going into the Canadian Prairie and into the Upper Mountain West, with some troughing coming into the plains. Now, what does that particularly do? Well, you can see the ultimate flow pattern here in terms of where the air is coming from is no longer, and we'll accelerate this a little bit further. You can see the majority of that flow is no longer coming from the southeast. In our particular case, it is coming from the Canadian Prairie, the Hudson Bay, much colder regions. And I would expect this to kind of not only kind of shut off a lot of the precipitation, at least in the middle part of the month, but also create a lot more cooler conditions. I won't say cold. I think our window is pretty much past for getting a big shot of Arctic air, and plus the polar vortex is still highly stratified and over Siberia. The MJO is not in its right area where it should be to displace that still. So therefore, I'm not anticipating a big Arctic outbreak by any means. I'm just saying cooler. So like for us here in the southeast, that might be like 45, 50-ish in terms of what we can expect in terms of temperatures. And of course, that lends itself to a little bit less of a moisture return as well, maybe keeping it more towards the coastal regions of the area as well, until we can get this omega block set up. It's not a full omega block, I will say, but it's certainly kind of the pattern associated with it if we have deep ridging across the Rockies. And we'll see how long that particularly lasts before we start to warm up again, looks like in the latter portions of the period. And we can see that reflected in the ensemble GFS anomaly here, days 10 to 15. That conversely, you see a very mild conditions, anomalously mild conditions across the Northeast and the Great Lakes states in the Southeast. Largely replaced, we see that deep ridging effect creating much more heat across the west, and then the flow coming in from the Canadian Prairie is working to cool off the eastern seaboard, with actually more ridging associated with Greenland as well, displacing even more cold air, which I think is kind of a verification of that particular forecast. And we can see that outlined by the Climate Prediction Center as well. If you compare to weeks 3 to 4 temperature precipitation outlook, we can see that precipitation is mainly confined to the coastal regions. It's equal chances, not saying it's going to be drought by any means in these areas, but it's just equal chances and above average chances for more precipitation across the eastern seaboard. And then instead of having just a giant map of red, which is what we've had here over the course of the past month or so, we instead get a nice channel of equal chances of both of anomalously cold or warm, and then the desert southwest going a little bit below based off of being in the lee of the mountain range, and also in the dominant flow pattern of the Canadian Prairie as it starts to, as that air goes up against the mountain ranges. So that's generally what we're looking at there. And that's pretty much all I got for you today. So today we took a look at the short term, we took a look at the medium term, we took a look at some potential concerning long-term teleconnection concerns that we have. Definitely good stuff to keep an eye on. But that's it. All I got for today. Do appreciate you subscribing to the channel if you are so interested in videos like this. I'll be back on Friday for another forecasting video, and until then, take care.